Hey class, Lieutenant Commander Streetpack. We are working through our jet log for the Big Brown Creek scenario. Just to familiarize again, we started at Big Brown Creek, which was on our chart. We found it wasn't really a point at all. It was just some random right next to a water source, and then Huntsville was a field, and then Cimarron was again just some arbitrary point, an old airfield basically. So we got those 3 points, and then we used all the given data that they gave us to do pre-flight wind calculations. Now we're in the in-flight scenario where you find yourself over a 784-foot tower located at this location. Okay, so the first thing you gotta do is find it. Okay, so for this scenario, we don't have to do any sort of magnetic variation fixing for that. All we're doing now is we're trying to find this tower, and then when we find the tower, that's where we're located. Okay, so we gotta look for it. 3120, and so 31 is over here. Oh, I'm sorry, it's not. 3120 is. Oh, I'm sorry, that's the third point. Never mind. Yeah. 784-foot tower. Okay, 3120. So 31 is here, and 20 is around here, okay? And already we kind of know where we're going to be. We're going to be probably right here. But let's double check the longitude. 9547. There's 90. 95's over here. All right, 9530, 9540, 41, 42, 45, 46, 47. All right, yeah, it's literally right there. Okay, cool. So that's our point. That's where we're located. So what we're going to want to do is get our track. So now that we've found the point, what we can do is take our divider, put it on where we started from, okay, and then drop it down on that location. So we're right here, all right, and so now that we have that, we can get a direction. So don't use the isoconic line, use the longitude line. Okay, there we go. And estimated direction, southeast. So once we are ready, okay, we just look up at the intersection, look up, and we have, looks like 1, we're going southeast, 155. Okay, so bracket 150 to 160, so 155. So we'll put that in here as our track. This is track, okay? We also want to get the distance, all right? So distance is, okay, 30 minutes, 31, 32, 33. 33 nautical miles. All right. Now they told us after 6 minutes and 12 seconds. So I put that in there. That's actually is a 0.2 for minutes, so it's 6.2. All right. That's useful when we are calculating our fuel flow numbers. All right. We can also update our time here too. So it's 20:06 12. Cool. So now we have an updated time as well. So if there's a question, so somebody didn't refer to in the last slides, but if you're doing this and one of the test questions says like, hey, what's the distance to your fix or something, and that was maybe question like 46 or something, then you want to stop and make sure that this matches what the test answer says. And if it's slightly off, like if it's 32.5 or something, you're just gonna erase it, put the 32.5 in there, and then keep going. So yeah, all this stuff, make sure it's all gouged out in terms of like question numbers, that kind of stuff, and then keep going, fixing as you go. So chronologically as you go, fixing it doesn't mean the problem number is going to be in chronological order, but your flow should be in chronological order so that you're not getting snowball effects as you're going on. All right, so we got that done. Now it's time to do the in-flight wind calculation. But well, It can be, not, but I still have my plotter and my divider out. So this is what I'm going to do. I'm going to go ahead and measure the course to get back to Huntsville, okay? Because I know that I'm off course. And well, what I haven't done yet is actually drawn the course line, so I'll do that first. So here's the point, and you know that the tower, 784-foot tower, there it is. Okay. Okay. So that's done, and then I'll draw one more here. Looks about right there. Okay, now that's done. I will measure the course and distance for the new lake. So I have got my 2 points there anchored down, and now I just use my plotter on my longitude line or latitude line. I'll try. Let's do latitude this time. See if we can get it. All right, so we're going southeast. Okay, so now I look for a southeasterly direction. And so what I have here is, if I use the bottom scale, so like the 4 scale right here, it's between 160 and 170. At the very edge, it says 164, so that's the direction I'm going to go in. So 164 degrees, and there's 35, 36 and a half. Okay. Now I'm done with chapter 2 altogether as it relates to the jet log. So I can just get rid of this thing. And I'll put the notepad over here just in case I need it. So at this point, I'm going to do my in-flight wind calculation. Okay, so what do I need for that? I need my track. Okay, so this is one thing. I'll go ahead and use the highlighter to help. So I need my track. I need my true airspeed. I need my true heading for the first leg, because that's what I was flying. Okay, and then I need my ground speed. But don't use this one because I didn't actually fly that ground speed necessarily. I flew whatever I flew in the 33 nautical miles in 6.2 minutes. Whatever that calculation is, that is going to be my ground speed. So there's my 4 pieces of information. First thing I'm going to do, estimate. All right, so in-flight wind, and then that's where I'm going to put it. Okay. My estimation for my ground speed is 33 over 6.2. All right, so that is something like over. It's like over a like a 5-to-1 ratio. So it's about 5-to-1 or 300 knots, right? So that's my estimation. All right, so now let's solve. So we'll use our whiz wheel, and I put 33 over 6.2. 1, 2, 3 over 6.2. There's 6. There's 70. So there's 60. There's 70. 6.2 is 62. So it's right there. Okay, so 30 again. 33. 31, 32, 33, 6.2. Okay, so that's set. My ground speed will be right there. So it's actually 320. So ground speed is 320 knots. And now I have everything I need solve my in-flight winds. So compare 320 to 275. That difference gives me a tailwind or a headwind. I have a greater ground speed, so that's tailwind, right? Now we just do the math here. So 11, so 5, 4, 45 knots of tailwind. All right, got it. Let's get my 45 knots tailwind, and then I have to compare my track to my true heading. So it's so I can do what I'm going to do over here in the corner, my little flinty heading first, 165. Okay, 155 is over here. So 155. So I have looks like a 10-degree drift angle. Okay, 10-degree drift angle to the left, which means I have a right crosswind and I have a tailwind. So my wind's going to be somewhere from there. Okay, and then so 10 degrees of drift angle using the 10% rule is going to be greater than the 9 degree, right? So it's going to be over 41 knots of crosswind, which is helpful because we might think it might be 4 or 5 knots or something, but yeah, it's going to be over 40. All right, so let's go set up and solve. All right, so the first thing we do is, again, make sure our true airspeed is set. So that is 275. Got it. And then we put our track, which is 155, at the top. Okay, I'm going to erase my old wind. Okay, I'm going to plot a tailwind of 45, and that's going to intersect. So tailwind to 45 is down here, and that's going to intersect whatever my crosswind component is. And I have 10 degrees of drift angle. And 10 degrees of drift angle gives me this much crosswind. So we're running to the nearest knot of crosswind, and that looks like it's between 45 and 50. Let's see where that lies. 46, 47, 48. So 48 knots of crosswind. And it's from the right, so 48 and 45 is what we're looking for. So there's the middle, there's 45, and 48's, close to 50, so it's right about here. Okay. So using a pencil is not a bad idea because it's fine tip, so that's what you want. All right, so you probably didn't just see me do that. Let's do that again. Sorry about that. So we have 155. It's my track. 45 or 48 of crosswind and 45 of tailwind. Gives me a point right here. Okay, we turn it up to the top. Read the wind direction and the magnitude, and we're done. So it looks like it's in the middle of between 60 and 70, so it's 65 knots. And the direction, make sure I'm not messing that up, is 287. So in-flight wind is 287 degrees at 65 knots. Cool. That wind is what we're going to use for the rest of the leg. So I'm going to circle it, and I'm ready to go. So, like I said, I got my wind circled, and the dots there, so I'm going to get my components as we turn these up. All right, so I got my wind. We'll get to the fuel flow rate and everything for these last couple legs, but anyway, we're ready to go. I'm ready to just pick it up. So this is where a lot of people stumble, is what do I do with that wind calculation? Well, first write it down, 287 and 65. Double check it's still there, right? And then you're like, all right, time to do pre-flight winds again because you have the next leg and you have the next leg. It just eerily reminds you of this part right here. And it is. It's the same thing. You just have a new wind now. You still have the same true airspeed. You still have the same fuel flows. You just have to update the times and the fuels as necessary with the new winds, okay? And all the information that comes with that. So the first leg we got to do now, pre-flight, is 164. So our winds are in the right place. True airspeed's in the right place. 164 is over here. All right, got it. Now we're looking to see where the wind is. It's over here. It's a tailwind. It's a tailwind of like 46. I'm sorry, 36. 36. Sorry about that. So a tailwind of 36. Okay. Then we have a right crosswind of 55. Okay. So we know based upon the 10% rule up here that it's greater than 9 degrees of drift, okay, or crab, right? It's the same thing. It's an angle. It's gonna be greater than 40 some knots, or 55 is greater than 9 degrees of crab. So let's double check that. 275 is up here. 55 is here, and that gives me right between 11 and 12. And so I'm gonna go round up to 12. So we're right 12 degrees of crab angle. So we got everything we need. True heading, right. So plus 12 with 164. So that's 176. And then ground speed is a tailwind, so we're going to add it to our true airspeed of 275. So 275 plus 36. So plus 30 would be 305, and then plus another 6. So 311 knots. Okay? All right. Next leg. So now we have a new course of 208. Our wind is still from the right, so we have a headwind now. Oh, am I in the right spot? I'm looking in the wrong area. Here we go. It still works. You just looking in different spots around a 360-degree compass card here, pretty much. So there's 208, and then there it is. So I got a 64 knots of right crosswind. So right crosswind is 64, and I got a 12 knot headwind. Okay. So now we take the 12, we subtract it from 275. So our ground speed is 263. And then right crosswind, again, it's going to be greater than 9 degrees of crab, but let's just verify. So 275 still there. Go to 64, way over here. There's 60, there's 60 to 70. 64 is right here. So it's less than 13 and a half, so we're going down to 13 degrees. So right, 13 degrees of crab angle. Cool. So adding 13 to 208. So its true heading is 10 plus there's 21. Awesome. All right, so now we have the headings, and we got our ground speeds. We can do ETEs, fuel flows. All right, estimating my ETEs. I have, this is about 6 to 1, right? Because it's 300, I'm sorry, 5 to 1 ratio, 300. So 5 divided by 36 is 7 minutes. It's going to be over 7 minutes, maybe. So let's try that out. So we have 311. Okay, so we want to use 6, 7, 8, 9. There's 30. There's 31. There's 31.1. It's right about there. Okay. So we got that in there, and that's the ground speed. And then we go to 36 and a half on the top. So actually, it's not very far away. There's 35, there's 36 and a half. So we look down, and it looks like almost 71. It's like 70.5. So it looks closer like it's to a 0.1, so it's like a 70, about 7.1 or 7 point. No, it's a 7.05. 7.05. So think about that. What's a 0.5 value of seconds? That's not, so 0.1 would be 6 seconds, right? So this would be 3 seconds. So it's 7 plus 3 seconds. Cool. All right, and then next you have 41 nautical miles using a ground speed of 263. So now we switch it up. 263 is right there. So that's 250, 260, 262, 263. Okay. All right, so then we have that, and looking up 41 nautical miles right here, and it's really close to 93 or 94. And about 94. So it'll be 94 or 9.4 because, yeah, it makes sense. So 9.4, we've gone longer and we're slower. So having a longer time to get there makes sense. So 9 plus and 0.4 times 60, or 4 times 6, 24. All right, so now we have our times. We just update them. So 203, 13, 15. Okay, and then we add 24 to this, so that's 39. And 9 minutes plus that, so 20, 22, 39. Okay, cool. Now we have our updated times. Last thing we want to do is update the fuel numbers. So again, fuel flow is always the same, 760. Okay, we got that set. And my estimate, again, 6 times, let's just say 6 times 13, right? Or yeah, that's probably fine. So it's like 60 and then almost half of that. So it's like close to 90 or something like that. So we got 760 set. Go to 6.2 in the denominator. There is 6.2. We look up, and it looks like a half a pound. So it's 78 and a half. Cool. All right, let's do the next one. Fuel flow doesn't change. So we're talking about 7.05. 7.05 is right here. That's really close to this right here, 89 pounds. And we can keep estimating if you want to, but just understand that these times are not very far away. You just know that this number is going to be more than that one by a little bit. And so is this one. This one's going to be more as well. 9.4 is a little bit further away. There's 0.4 here. And it looks like it's right next to 11.9. So 119. Cool. Now we're ready to update the fuels. So 2000 minus 78. Oops, not 2000. It's definitely losing fuel here. So it's 1, 2, 1, 5, I believe. And then the next one is 89 pounds, subtracting from there. It's still going to be a 0.5 value. We're just subtracting, let's see, 9 from that is 12. And then what's 80 subtracting from there? Yeah, this is hard. So we'll just do this. 89. 2, 3, 1832. Okay, and then subtract 119 from that is 5. There we go. So let's just double check all this stuff, make sure it makes sense, right? Because we don't ever want to get in a situation where we do bad math or something. So if we subtract 78 from here, it'll definitely be 1800s plus some extra. All right, so I'm sorry, from here, yeah, 1921, good, and then 89 from that, so it's close to 90. So it'll be just a little bit over 90, subtracting 90. That makes sense. And then over 100, so definitely getting lower. Good. Okay, cool. These numbers work out. I'm happy with what I did here. These may not be what you guys get, but it might be close. If you're way off, then please double check your work and make sure that what I was doing here matches what you were doing. And if it doesn't, then keep working at it, and hopefully something that I did fundamentally here. But if so, give me a text or message your instructor, and I hope you guys learned a little bit on how to do this stuff. Happy studies.